Good afternoon, my name is Josep Martrat and I'm the head of Telecom, Media and Edge Technologies at Atos Research and Innovation Department in Spain. Here I'm introducing the applicability of artificial intelligence technologies as a basis for having a connecting intelligence in smart orchestration for 6G networks. The vision of future 6G systems is a complete interconnection of human, physical, and digital worlds as different dimensions that seamlessly interact in order to support new services. An essential element to empower this 6G vision will be the extensive use of artificial intelligence within the network orchestration in order to cope with the envisioned heterogeneity and distribution of these infrastructures. So when you look at the complexity and the challenges for managing future 6G systems, one of the first topics that you may think about from the management support system point of view consists in orchestrating the so-called far edge, in which there can be any sort of devices, such as sensors, cameras, mobile, robots, and drones. According to the physical location and the relative distance of these computing resources, you have likely heard qualifiers such as extreme edge, far edge, near edge, up to the cloud. If the reference is based on the capabilities and capacities, you can define it as the thin edge or the micro edge or the cluster edge micro data center, or up to typically the multi-cloud hybrid situation. If the purpose or the focus is the purpose and the remit of the functions that are being executed, you have the radio access functions, like the distributed units if it is an open RAN approach. You have the core functions executed at micro data center, or a user play function that can be extracted and executed at the edge, or other core functions like the network data analysis function for analytics at the edge, and also, of course, the application service functions running. The point here is that there is the need to have an integrated management of this computing continuum across these different segments. The extreme edge and far edge resources have several characteristics that make it special and challenging. One of them is heterogeneity of devices, as I mentioned. The other is, normally this is an uncontrolled and asynchronous environment that you need to manage. The volatile behavior, some of these elements can be disconnected and the situation is more random than a control environment. The diversity of the supporting hardware technologies. You can have CPUs, GPUs, some hardware accelerators, etc. And this is definitely a huge, massive digital ecosystem that to control, and also the need of having a small virtualization footprint. I mean, it is not only to have a containerized virtualization like Kubernetes, but even lighter versions of this, like micro Kubernetes or K3s or kubeless if it is a serverless situation. The Connected Intelligent Research Challenge consists in turning artificial intelligence machine learning to an essential component of 6G technology. AI will enable the implementation of predictive orchestration in 6G. For instance, to do some optimal placement decision across segments, or to have a completely end-to-end management of this continuum. And this would be achieved based on reference training material, or the use of neural networks here, or the use of the multi-agent reinforcement learning in some elements, some parts. And this is part of the network programmability, in fact. So AI will enable networks to faster and more precisely adapt to scenarios and traffic demand. And there will be a comprehensive exploration on the potential of AI to monetize the network and the application data, while enhancing the cost, the energy consumption, the service efficiency of the network infrastructure. And sometimes to define some performance target is not easy and requires some consensus and to take something as a reference, and this needs to be fixed. From the service management perspective, artificial intelligence machine learning will be needed to maintain the operational cost effectiveness for the support of much more complex services, and this will come with the 6G era. Requirements from these human digital physical worlds interactions, or the so-called Internet of Senses. The multiple virtualization technologies that exist, including virtual appliances, microservices, containers, serverless functions, and its interoperability, will be also increasing also the complexity of the network operation. So we expect that EA mechanisms will become crucial to automate the operational part and the decision-making processes. There are some smart orchestration features that will be further explored and developed in HEXA-X project. 6G needs to deal with more complex and heterogeneous service definitions, and therefore the descriptors need to be adapted. The use of artificial intelligence needs to deal with huge amount of data generated at all levels, infrastructure, platform, and service level. And this needs to be efficiently collected, filtered, analyzed, and processed for better decision making. Another is how to enforce the predictive actions for faster adaptations. This implies multiple actions for optimal placement of virtual network functions, taking into account, for instance, the associated devices and their geographic density, as well as the service, or for instance, deal with the network slicing, efficient configuration of the slicing and its maintenance, or the elasticity of the slicing itself. Scaling actions or doing self-healing based on real-time needs and the availability of resources, network and compute resources, in order to offer in the end a service continuity over this continuum, accomplishing a zero-touch approach in operations. There are multiple approaches for the integration of AI techniques to the management and orchestration. One approach is the integration of the adapted AI solutions within each domain, within the core edge or extreme edge domains, applied even in a very granular way at the level of individual devices, or for instance, by means of the federated learning agents. Another approach would be to apply AI techniques more globally through the continuum orchestration function, integrating data from the different domains, for instance, mixing application and infrastructure-based cognition to trigger self-adaptation or self-optimization decisions. That could be based on predictive mechanisms or explicit intent-based requests. These triggers would be used globally to perform continuous autonomous functions to smoothly anticipate future status and potential problems of the network. And there are plenty of actions that can be done, like the replacement, optimization of virtualized network functions, a change of the slice instantiation request, scalability decisions, migration among domains, or anticipation of network function reconfigurations. In addition, we need also to have methods for ensuring the AI will be secure, trustworthy, sustainable, and explainable itself with respect to the resource consumption and the performance delivered and the decisions that has been taken. So this falls somehow under the research scope of the in-network AI governance. There are many key references and ongoing work in some standardization organizations about the usage of AI in management and orchestration. Just to mention some of them, HEXA-X group that proposes the complete architecture, although the interfaces in order to pass the commands towards the NFV Mano assisted system is pending. Also the HEXA Zero Touch group, 3GPP has also proposed a function and the radio for EA-based function interacting with the network and the applications. TM Forum in terms of the best practices, or more recently the I2 working group in the autonomous networks. And there are also other references and ongoing work in open communities like ORAN Alliance that has proposed an initial AI deployment framework for the radio access management, network management. Also, the NFV Mano initiative, OSM or ONAP, has POCs and functions in order to introduce AI in the control loops. And of course, several ongoing or past projects on the 5G PPP. Here I summarize some challenges in extending the use of EI from the current 5G implementations to 6G for management and orchestration. Due to increased complexity and the heterogeneity imposed at the far edge in 6G, network service management mechanisms will be challenged too. Also in terms of automation and network programmability, it will be more complex in order to provide the required dynamicity and reliability and resilience and for an optimal use of the resources. It is clear a challenge on the harmonization of the monitoring and the data extraction, filtering and processing at the edge in order to have these decision-making processes to support the orchestration. Security is an obvious case for the integration of the stream edge and also the aggregation of different stakeholders. And in fact, this together with the trend of the function disaggregation, network function disaggregation, creates new challenges because there will be more stakeholders involved in the deployment and the hosting of network services. And in fact, you need to come with a complex multi-vendor 6G ecosystem. And that's all on my side. Thank you.